All right, so we're going to take a look at question B. Now, remember, I expect that you will do this problem first and then watch the video. So if you haven't done problem B 1, 2, and 3, please stop the video now, pause it, do the problem, and then come back. Otherwise, you're really not going to get much benefit. Learning happens best when you do something and then check it and correct it. Okay. So with that in mind, question B1, here we go. So we have y equals x squared plus 8x plus 12, and we are being asked to find the important points of a parabola. And we'll remember that the important points of a parabola are the x-intercepts, the y-intercept, the line of symmetry, and the vertex. And just for a quick little review, the x-intercepts can be found in the factored form expression. The y-intercept is going to be the expanded form. The line of symmetry is going to be directly in between the two x-intercepts. And if you want to write this little cheat sheet out, that's not a bad idea. And so the vertex has the x value of the line of symmetry, and then you have to plug in the line of symmetry value, the number, into one of the equations to find the y value. So that's what we're going to be doing here. And in question 1, they give us the expanded form expression. Now, in the expanded form expression, we have 3 parts. We have a quadratic term, and this is called the quadratic term because it is squared. That's why it's called the quadratic term. If we just graph y equals x squared, we'll get a problem. The middle term is called the linear term because if I graph it, I will get a line. And the final term is called the constant because it will not change. It is constant. The y-intercept is the constant in the expanded form expression. So we know right away in problem 1 that the y-intercept is 12. Hey Matthew, okay. So then for question B, for the x-intercepts, I need to have it in factored form. And so the question is, what times what is 12? But if I add the same numbers together, I get 8x. So, well, 6 times 2 is 12, 6 plus 2 is 8. So we get the expression x plus 8 times x plus 2. And that has to equal 0 at the x-intercepts. So I'm going to take a little red blotter here, and I'm going to cover up. Not quite cover up, but you know what I mean. We're going to cover up the first binomial, and the question becomes, what number plus 2 is equal to 0? So what plus 2 is equal to 0? Well, that's negative 2, right? So one x-intercept is negative 2. All right, so then I move my little rectangle over here. What something plus 8 equals 0? Well, that's negative 8. Negative 8 plus 8 is 0. So my other x-intercept is negative 8. And yes, it will follow that pattern. It will almost always be the opposite of the number that you have here. The only difference is if you have a number right here. But we don't have that yet. And I need to talk louder because I realize the microphone is farther away. All right. So the line of symmetry is halfway in between negative 2 and negative 8. What number is between negative 2 and negative 8? Well, negative 5 is directly in between negative 2 and negative 8. So my line of symmetry is x equals negative 5. For those of you who don't know how I got that, all I did was I added the two x-intercepts together and divided by 2. In other words, I found the average of the two numbers. And so for the vertex, I know that it's going to be at negative 5 comma something. So let's plug in -5 for x. So using my factored form expression, I will have -5 plus 8 times -5 plus 2. So -5 plus 8 is 3. -5 plus 2 is -3. So 3 times -3 is -9. And so there we go. We use the factored form expression to find the x-intercepts, the expanded form equation to find the y-intercepts. We took the average of the two x-intercepts to find the line of symmetry. And finally, we plugged in the line of symmetry for x to figure out what the y value for the line of symmetry is, and then we gave the point. All right, so let's do the same thing, because math is nothing more than following a pattern, and the pattern is not going to change. Hasn't changed since human existence. It's not going to change for you in your lifetime. I don't know if you find that depressing or not, but I'm just filling time as I erase. Okay. So our next equation, we have y is equal to x plus 3, x minus 3. I'm going to write that down. We have x plus 3 times x minus 3. To find the x-intercepts, it has to equal 0. So x minus 3 has to equal 0. Well, the only way that works is if x is equal to positive 3. If I slide this over here, something plus 3 is equal to 0, so my other value of the x-intercept has to be -3, because -3 plus 3 is 0. So I got -3 and 3. All right, so for my y-intercept, I need the expanded form. So let's multiply that. Oh, wait a second, this is a difference of squares. And I know difference of squares, the linear term is going to cancel out. I'm going to get 3x minus 3x, which is 0. So my expanded form is just going to be x squared minus 9. So there we go. Here's my constant term. So a difference of squares has no linear term. So what number is halfway between -3 and 3? Well, that's pretty easy. That's just 0. So all differences of squares will have the line of symmetry on the y-axis, which makes life really easy, because then the vertex is just the y-intercept, because that's where because we already know what y is when x is equal to 0. All right, problem number 3 is really similar to problem number 1 that we did in class. We have it in factored form. So we have y is equal to -x squared plus 6x. So the question is, what times what? Oh, wait a second. X goes into both of these terms, doesn't it? We have a greatest common monomial. So we have a greatest common monomial of, and I'm going to actually factor out a -x here, because I really want to start this with this expression with in the parentheses with a positive. So -x squared divided by -x is just positive x. Now, if you didn't use the negative, it's okay. You could still get the right answer, so don't fret. Positive 6x divided by -x is -6. All right, so now we have our factored form expression. Now, I don't feel like using the rectangle, so hopefully at this point we see the pattern. This x is going to give me a x-intercept of 0. This x is going to give me an x-intercept of positive 6, because positive 6 times -6 is 0. So making my little table up here, we have our x-intercepts of 0 and positive 6. My y-intercept, well, I'm not adding, I don't have a constant term here. So what can I add that doesn't change anything? Well, that's just 0, right? So I can put in 0 here. So if you're factoring out a greatest common monomial, you'll have a y and x-intercept that is 0, and that's okay. So my line of symmetry is the number that's halfway between 0 and 6, which in this case is 3. And so we need to plug in 3 into our equation. I'm going to use the factored form because I prefer using the factored form, but you can use the expanded form if you wish. So we have negative 3 times 3 minus 6. So 3 minus 6 is negative 3. Why are we getting so many 9s? You think that they could come up with a problem that doesn't end up with a 9, right? So we get negative 3 times negative 3, which is in fact positive 9. So we get a a vertex of 3, because we're using the line of symmetry, comma, positive 9. Now, of all of these, this is the only one that opens down. These two both open up. And the reason why that is because the x squared is negative. So if you have a negative quadratic term, then you will get a parabola that opens down. A positive quadratic term has a parabola that opens up. I hope you enjoyed that.